So, from home, uh-oh, everything dangerous in here? Good, I don't. So what you can do is go, now I can't see it, darn it. Freak is the mouse. If you go to your Canvas site, oh my gosh, this is awful. What is going on here? Courses? Come on, do it. So you should start Canvas in this standard site. If you then pull to the pull down, you'll go to CHM130 for you guys for the afternoon. I'm pretty sure you're the 3314. So we go there and then to the announcements tab. Homework running tally is what you're going to look for announcements. When you go ahead and click that, it now has the PSS homework, and now it's been updated with the Chapter 2 homework. So I will continually update that one section for all the homework questions. Okay, so if you keep coming back to that announcement, you'll find all those questions lined up. Okay, so that's how you can find that information online. You will also see it in the slides when I post new slides. Everything that we're going to talk about today, you've already seen, or we already have the slides for. The slide order may be a little bit different, but you have the slide in front of you if you've printed it out, okay, or if you're looking at a digital copy of it, except for this one, because that's my fault. So these are your homework questions. Other things that you should be worried about, particularly when it comes to the exam, would be things to memorize. We've got that element list, which is on Canvas as well under helpful files. And then another thing that you need to be concerned about would be your metric prefixes. I'm positive there's something else, I just can't remember what it is. The metric prefixes you're also going to need to memorize. So what's the symbol? You could probably get away with just the symbol and what scientific notation it applies to. So like kilo is 10 to the third. So those correlations. We'll see that table that shows them in just a little bit. Yes?
I just know that the exam is coming up soon. Is there going to be a study guide?
I am going to try my best to put together some kind of study guide that summarizes individual sections. One of the hopes is that we'll be able to finish this chapter, worst case, halfway through Thursday's class. And then we can spend the rest of Thursday's class kind of reviewing the big topics and things you should have for the exam. That will be the hope. We'll see how that goes. Because it's the first time for me doing this class, I don't have any extra notes or handouts or anything like that I can give you to give you extra practice. So really all you've got is what's here, but that also means that's really all I've got as well. So a lot of the questions that I'll be using will be coming from the lectures and from the homework questions that I set up. And I may switch numbers around, that kind of thing. Okay? If we do a couple problems today, we'll actually shift it into a multiple choice format so you can get an idea of what kinds of answers you might expect and what kinds of questions. Other questions? Yes? You will not need Scantrons for the test. I will cover that in one form or another. Which reminds me, I really should get that covered soon. But I'll deal with that, not you. Other questions? And since that was a couple questions on the test, that makes me a little bit nervous. The test is not next week, but the following one, right? Okay, I'll make sure.
It's on the 17th, right? Yes.
That means nothing to me, so I'll say yes. All right, any other questions? So.
Is this homework due before this test or for the
This homework will be due with the test. So the first test is going to cover from the 7th edition, Chapter 1, 2, 3, and PSS. If you're using the 6th edition, I believe it's Chapters 1, 2, 3, 4. All right? Other questions? You like tests, don't you? Okay, so general kind of review. Remember, your sig figs. You need to be able to know these rules. So this could be something we could add as a memorization. You have to be able to apply these rules for every new problem. As we started to look at we can go through and do different addition and subtractions and multiplications and divisions. As we process these operations, these mathematical operations, we have to keep in mind the sig figs, okay, our significant digits. We need to have that information always readily available. Every time you output a number, you have to interpret, are your significant digits appropriate? For this class, and probably 151, any lecturer is going to really just harp on you all over significant digits. So if you end up giving the wrong answers with significant digits, you will lose points. Further chemistry classes tends to be, they get more and more lazy. I would know because I'm one of those later and later professors. And we stop caring about sig figs. Okay? So you can do additions, subtractions, multiplications, divisions, and then you have to apply those significant fig rules in these different types of operations. On top of which, we then also have to wonder about rounding. So you also have to know your rounding rules as well. I got to fix that, make that a greater than sign. Okay, greater than equal sign. So in the case of, sure, why not? Let's go ahead and do it here. Let's say on the exam I gave you this question. Okay, our question was to add those two masses. So there's our question. Ding. First thing that you would do, anybody? You're probably going to add it. Okay. You'll probably also use a calculator. Calculator is going to spit out that answer, 1.335 grams. So if you take a look at your answers, one of your answers, 1.335 grams. Because your calculator told you that. If you don't know your rules, what happens? You circle that answer. Are you right? No. Okay, so you have to make sure you apply each of the rules. Other answer choices might see 1.3. You'll notice the difference between 1.3 and 1.335. They have the exact same sequence of numbers in them. So nothing jumps out as particularly wrong. I think the next one will be. And usually, there's almost always A, B, C, D, E. At this point, any ideas what else I could give as an answer? I'm kind of lost too. I don't know what else I'd say. So for this morning, I said goats. That's fair enough. That is a possible answer. So your first approach at this problem, one of your options is to add it up and get that number. You then have to analyze that number, right, and verify what your answer is going to be. Another option is to look at the possible answer choices. So you've got A, B, C, D, E. Immediately, what should you do? You should probably eliminate goats. I might be wrong, but I'm pretty sure when you add those two numbers, you don't get goats. Right? That increases your odds. Okay? With a multiple choice exam, take advantage of the multiple answers and try and whittle it down to the point where you can improve your odds of getting the answer right. The next part is then processing the rest of those, and that becomes a little bit more difficult because all of them have something in common with what your calculator spat out. Okay? So to go through and answer this, we now have to approach based on the significant digits because it's really all that's changed with the rest of those answers. So to do that, we'd have to go back to our question, say, okay, what operation did we do? We added. According to our significant digit rules, how many digits are we allowed to carry through when we add? Based on the least accurate, which happens to be our first one, that hundredths place. If you happen to have graph paper, this could be really awesome because you could then go through and mark that position as our significant digit. Anything after that is irrelevant. Anything that does not include that place, also not a good answer. So what does that mean? We could again eliminate B and A, because A has too many digits. Now, worst case, we're down to a 50-50 shot. We can take a guess at it and see what happens. All right. So the next rule that we would have to then apply would be looking at rounding. We take a look at the first non-significant digit in our answer, which I've got circled here. Okay. Hey, I even color-coded it. Look at that. If that first non-significant digit is equal to or greater than 5, then we add 1 to the last significant digit. What does that mean? Our answer becomes 1.34, bubble in D.
With the unit, right?
Ooh, yeah. Dang it. You start penalizing me. That's like the second time you've called me out on it, huh? And why not? Okay. Makes sense? Get an idea on what kind of multiple choice answers you'll see. So it's not just random things thrown at you, except for maybe one. Most of those answers will have some meaning that are feasible or reasonable things to put down based on what your calculator spits out. Okay? You have to interpret the calculator. Questions about that? Okay, let's move it up in the world. Next part is then when we move to actually bringing in bigger or smaller versions of our units. If we have a really big number, we don't want to include a whole bunch of placeholder zeros because our hand gets tired. So what we can do is remove some of those placeholder zeros in two fashions. One, we could convert it to scientific notation, and that would get rid of some of those placeholder zeros. But then that still involves this exponent, okay, and the power of 10. We could simplify that even further by converting that into a symbol, a prefix symbol in front of our unit, our base unit, right? Everybody comfortable with that? So you would need to have all of these kind of readily available. Officially, this is your memorization list, so I do expect you to be able to pull at these. As far as which ones I would test you on, most commonly, your kilo, centi, milli. The rest of them you could expect to show up, but I'll use those as kind of a way to delineate those people that just want to pass the class and those people that want to get an A in the class. Knowing the rest is kind of an A level because you spent extra time to memorize things that weren't quite as important, okay, or not quite as frequently used. The other ones I fully expect you to have memorized because you're going to use them a lot and we're going to keep referencing them, both in the lab and lecture. So I want you to have those immediately memorized. So you can expect to see those a lot. Questions about that? I don't know what was going on with that, so let's move forward. We could look at our fractional notations. So we went through and derived different scientific notations. On Tuesday, went from a big number, converted it into scientific notation, and then converted it into a new unit, right, just by breaking out individual pieces. We could also go through and instead of doing all of these scientific notational jumps, is pick a unit that we wanted and convert just to that unit without having to deal with our scientific notation, okay, if we didn't want to deal with it. So we could come up with these different equations or relationships. So in English, we could go through and say we've got 10 to the negative 2 meters in a centimeter. Mathematically, we spun that around and said we've got 1 cm equals 10 to the negative 2 m's, okay, or 1 centimeter equals 10 to the negative 2 meters. We then manipulate that even further into what we were calling, or your textbook calls, a unit fraction, and what I typically like to refer to as a conversion factor. And what's going on with that? We're going to take that straight line standard equation and convert it into a numerator and denominator. Okay, why does that work? Well, mathematically, what we have done is we divided, say in this case, we divided both sides of our equation by 1 centimeter. What is 1 centimeter over 1 centimeter? 1. This becomes really important when we go through and do conversions because we can now incorporate this conversion factor into our equation. We can introduce it whenever we want because all we're doing is multiplying by 1. So we take any number, multiply it by 1, what happens? Stays the same. We have the same effective relationship. We don't have to worry too much about it. The part that's nice is that we can then also convert our units around. And that's really what we're going to try and take advantage of with the rest of this chapter, is doing some hopefully relatively simple unit conversions in this fashion. Make sense so far? Okay. So another mathematical test. So let's go through and do these. In theory, you guys should all be able to do this. Without a calculator, when we try and process this, what's that first equation equal to? 3. How do you know it's equal to 3? 6 over 6 gives us 1. So 3 times 1, 3. So we could cancel those 6's out of our equation. We don't have to worry about it. What happens in the next one? Okay, we get 12. Why?
3 goes into 12 4 times.
Our 3's can cancel each other, and we got 12. Last one. Okay. We could notice that 16 is 4 times 4. We can cancel 1 4 in each case, and we end up with 3/4. So what we're doing is mathematical. Why did that not write? There's a 3/4 there, I promise. Usually didn't lag that badly. I may have lost the internet connection. I think I did. So we've got, now it draws it. That last one is the one I wanted to look at anyway. Okay, we've got our 3/4 as our answer. The reason I bring this up is because if we now went through and changed these around a little bit and said for this first one, instead of 3 times 6 over 6, I wrote 3 times m over m. Okay. In general, and this applies to everybody, we all of a sudden see the m's and go, oh my gosh, we can't solve this. Well, except m is just an arbitrary symbol. If I divide anything by itself, I get 1. So what ends up happening for our answer in this case? We just get 3. What would our units be in this case? Since you gave me such a hard time for it? Unitless. We don't have a unit to translate across in this case. Okay, the other reason I bring it up, if we shift down to our last example, let's say, and I'm going to rearrange this a little bit, let's say we take 3 times 4 over 16. Does that change anything? We still get 3/4? Right? We do, don't we? Okay. Let's switch it up and say that 4 is now an m. Okay. Again, this tends to cause a little bit of panic. Well, what goes on with this? Same thing as we did with the 16. We can say that m squared is the same as saying m times m. And what do? We can cancel one of our m's, and our answer becomes 3 times, what do I include after it?
1 over m.
1 over m. Why is it not just m?
Or it could be n negative 1.
Don't bring in the exponent. Where is our leftover m? In the numerator or the denominator? In the denominator, which means when we write out our answer, where should that m be? In the denominator. Okay? So we can sometimes get odd units. That's fine. Okay? In this case, it's 3 times 1 over m. Okay? Our unit, in other words, would be per m, or per meter. Okay? So the idea is that the mathematics, the numbers that you've seen before, we're now using letters in those same positions, but they're going to act the exact same way as the numbers did. Nothing's really changed as far as that material goes. Does that make sense? Because it only gets more complicated. Okay? So what we're going to go through and do is do some unit conversion. And this is usually where people get thrown for a loop. So we're going to start a little bit easy. How many inches are in 3 feet? 36. Good. Everybody's got the right answer. I agree. Okay, there are 36 inches in 3 feet. How did you do that? Can you walk me through that? What did you do? 12 times 3. What's the problem with that? And I'm going to write it around a little bit differently. I'm going to write it as, whoops, that's the next slide. I'm going to write it as 3 times 12. Now let me go away from it, have it pop up. Oh, maybe it's flipping out again. Okay, let's say we wrote out, you live, 3, whoa, now it's really big. 3 times 12. What's the problem with that? No units. Remember, every time you write down a number, there needs to be a unit attached to it. What is the unit on 3? What is the unit on 12? So what you guys just described to me is I go through and do this calculation, and I get 36, but I don't get 36, whoops, that wasn't supposed to happen. I don't get 36 inches, I get 36 feet inches. Did you guys do something else when you did that calculation? What do you mean converted it? What is this 12? You didn't multiply by 12 inches. What did you multiply? 12 inches in 1 foot, also known as 12 inches per 1 foot. What you did was took a unit conversion, our equation, 12 inches equals 1 foot, and you divided both sides of that equation by 1 foot. And you ended up with the equation 12 inches over 1 foot equals 1. You took that 1 and multiplied it by 3 feet. You've now done your unit conversion. Okay? You did that all in your head. Fantastic. I actually really like that. That's pretty cool. Unfortunately, what ends up happening is if you don't follow those unit corrections appropriately in your head, what happens to your answer? It becomes wrong. Okay? Even if you think you set it up right. And this is something we'll keep coming back to on this. Roughly 70% of the time, I can do this right in my head. I've been doing it for roughly 15 years. Okay, 70%. If I take a test and I get 70% of the test right, okay, is that a particularly good score? No. Okay, most people aren't going to be happy with that. So what do? I don't do it in my head, I write it out. Because when I write it out, my success rate is closer to 99% of the time. If I go into the test and get a 99% on it, I'm going to come out pretty darn happy. So it's going to come with your success rate. If you think you can do these conversions in your head, by all means, go ahead and do it. If you've worked enough problems to find out that your success rate is 50%, probably shouldn't be doing it that way. So if you ask me for help, I will make you write it out. I'll probably even write it out with you to check your work. Okay? There's no guarantee that it works every single time, but it gets better odds than if you attempt to do it in your head. So always try and write this out. So the reason we went through and did this was to come up with this format. What we now have is a mathematical format that we can then apply to all other problems, all other conversions. Okay, this method, this organization of looking at these fractions and multiplying and dividing, all this fun stuff, is what is known as dimensional analysis. Not quite sure why we call it that, but it works. Textbook will also refer to it as unit analysis, or the unit analysis method, or the factor label method. I call it works. Do whatever you got to do to get that answer right. Except cheating. Can't do that. Okay? So, textbook breaks this down a little bit differently. They go through and say we've got 3 main parts, which is also what we did. We've got 3 big deals. We start off with the answer. Okay, why should we start with the answer? Because we're optimistic and we like solving for the answer first. So a good place to start all problems is put down an equal number and put down whatever number or whatever information you know about your answer. Okay, if all you know is the unit, that's pretty helpful. You may not know the number, but at least you've got something. You've got a target. You can then go back to the beginning part of your problem and try and write down what information was given. So each of these problems, you're going to be given both step 1 and step 2. Your job is to figure out what happens in step 3. And that's going to be the unit factor conversions as we pump through these. And we can break down those unit factors into multiple calculations if necessary, or we can do it as one big sweep, okay, if we want. We'll see both methods in a second. Questions about that? Okay. So let's start with another simple example to kind of work our way through it. What is the mass in grams of a 325 milligram aspirin tablet? Where should we start? Get some information about our answer. What do we have? We know our answer is going to equal something. And what do we know about it?
In grams.
Our units need to be in grams. Are we given any information to start with? Okay, we know that we started with 325 milligrams. That magic section in between has to somehow convert those milligrams into grams. Okay, so this is where I'm potentially a little bit different from the book. You can either, one, just have something memorized and throw it in there. If you don't have something memorized, take a stab at it. So in the process of doing whatever's happening in between, I need to somehow get what unit in the numerator. Numerator's on top. If we take a look at our answer, grams. So whatever my conversion is, I need grams up top. Okay. What unit needs to disappear? Milligrams. To get that milligram unit to disappear, what needs to show up in the denominator? Milligrams. So I can put it down there. Now I'll ask myself, do I know a relationship between grams and milligrams? And this is where I think back to self. Yeah, I do, because I was told to memorize that, and I did. So what is that relationship? Whoa, I keep doing that. There are 10 to the negative third grams in 1 milligram. Okay. Yes, there are other ways to represent that, but that's how your textbook's got it listed right now. So that's how I'm going to stick with it. Okay. What happens at the end of this calculation? What happens to the units? My milligrams cancel, and I'd be left with purely grams. So now what I can do is go into my calculator and do the simple calculator punching, and I have my answer, 0. There's not another 0 in there, 0.325 grams. Okay. So all we're trying to do is manipulate and understand it as best we can. Does that make sense? This next one I'm going to make you do on your own. And you got questions, you can raise your hand. Okay. So if there aren't any questions about this, you guys are going to run on your own. You sure you got it? Okay. That was not the right button. Not sure what that button did, actually. New question. What is the mass in micrograms of a 325 milligram aspirin tablet? Okay, so let's go ahead and give this a shot. Where do we want to start? We're eternal optimists. Let's go ahead and start at our answer. Equals what unit? Microgram. A lot of people complained about my drawing of that unit this morning. What is that symbol? It's a Greek letter mu. It is not an M. Okay, it is the Greek version of an M, so just be aware of that. Why is that particularly important? What did we start with?
Milligrams.
started with 325 milligrams. Notice, milligram is not the same symbol as microgram. Okay? Maybe a subtle difference, but keep them completely separate. Otherwise, it's going to make your life not happy. So our next attempt is to come up with that conversion factor. Okay, so my first pass at it, say, okay, I want to get rid of the milligrams, so those need to go in my denominator. And I need micrograms in the numerator. So now I go back and think, okay, did I have a relationship? Is there a direct relationship between these two? Should have kind of a pause there. No, we don't have a direct relationship with that. We know how to convert each of them back to something common. We don't have a direct relationship between these. Our relationship is coming back to grams. So I can convert milligrams to grams, and I can convert micrograms or grams into micrograms. So what we have to do is actually break this into 2 steps. All right? So that would be my first approach, or one possible option here, which means immediately my equals is in a very bad position because it's not going to equals directly across. So I'll shift my equals a little bit lower. Because in my first pass through, I don't have that relationship. I do know the relationship to grams. So we'll go through and set that up. So my new answer is now going to be converting it into grams. What's the relationship between grams and milligrams? 10 to the negative third grams is 1 milligram. All right? We go through and do that math. Definitely did not leave myself enough space. We would get 0.325 grams. That's definitely not what I was asked for as an answer. I wanted to convert it into micrograms. So I now have a new given information that I actually solved for. So we'll shift that information now to our lower line, 0.325 grams. And again, what's my conversion? Well, I need to get rid of the grams, so we'll put those in the denominator. And I want micro. Oh, geez, that one's really ugly. And I want micrograms in my numerator, so it translates through. Do I have that relationship? Right. This is one that you're required to memorize, but is one of the more difficult ones. Okay, so what we might end up doing is shifting a little bit. And we'd probably say, okay, I got to look it up, because this is homework. Let's spend some time and look it up. We know 10 to the negative 6 grams is 1 microgram. If we track our units now all the way through, all the way even from the very beginning, what ended up happening? In our very first step, our milligram unit was converted across into grams. In our second calculation, our gram unit was converted over into micrograms. So at our very end, we'll have our microgram unit answer. Okay. What ends up happening? We get 325,000 micrograms. Okay. That's breaking it into multiple steps. I personally don't like doing that because I've repeated information. So what I try and do is condense it into one line and do the calculation all together as one single step with multiple parts within. Right? So you guys first off comfortable with how this was solved for? Any questions about this before we condense it down? Okay, so we're going to erase it all. Start back up at the beginning. And I want to say I want to get to my microgram answer. I'm starting with 325 milligrams. This time, because we already did it once, I'll remember that I can't go from milligrams into micrograms, so I'll go milligrams to grams first. There are 10 to the negative 3 grams and 1 milligram. Oh, seriously. I swear I wrote that. You're going to make me write it all over again. Stupid computer.
Why can't you put the micrograms on top and the milligrams on the bottom?
Do you know that conversion?
10 to the negative 6?
The relationship between micrograms and milligrams? No. The 10 to the negative 6 is the relationship between micrograms and grams. So you have to be careful with your conversion. For those of you saying the 1,000 or the 10 to the negative 3, we'll address that here in just a second. It still goes back to that 70 versus 90% success rate. Is it writing? It better be writing. Our next conversion is to get our grams over to micrograms. Conversion, 10 to the negative 6 grams is 1 microgram. And if we track our units through, our milligrams cancel, our grams cancel, and we'd be left with our microgram answer. As far as what I would do in this next step, okay, mathematically, as far as a calculator goes, particularly for longer calculations, we're going to do one slight tweak. You'll notice that I haven't drawn a denominator on the 325 milligrams. Can I draw a denominator there? Yeah, what would it be? Just 1. So here's the reason why. So what I'm going to do is do all of the multiplication first. Okay, so I'll get my numerator coming out, and I would get 300 and, well, if we punched it into the calculator. Shoot, let's keep this color-coded. We would get, was it 0.325 for our numerator. What happens with our denominator?
Becomes a 10 to the negative 6.
Could include all those ones, or we could just say it's 10 to the negative 6.
It's not right.
Finish. Oh my gosh, it's killing me. What would the units be that I would include on this?
The top would be micrograms.
We actually already solved our units. We still have our micrograms. We can now punch into our calculator and finish that last step, and we end up with the same answer that we had before, which was, please be writing. If you don't laugh loud, people at home don't know that was a joke or doesn't think it was funny. Don't you need a laugh track, right? Distracted. Okay, so we end up with our final answer. The reason I would do that is breaking our numerator and denominator calculations out like that is if we start to string things together differently in our calculator, we might end up multiplying and dividing out of order of what our calculation actually said or what we actually wanted the calculator to do. So you have to be very aware of the order of operations of your calculator and how it processes things. Okay, if you got questions about that, you can talk to me outside of class. So we end up with this as our answer for our micrograms. How is this different than what we did before? The only thing that we really left out was having to deal with the 0.325 grams being written twice. Here we wrote it once, we're done. We didn't have to stress as much about writing it out. Again, this is a simple example. This was only 2 conversions. If you have to string together 6 or 7 conversions, it's going to be a lot nicer if you run it in one line as opposed to doing each of those conversions, individual conversions on their own. Okay? Make sense? How are we with that overall conversion? You guys happy with that? No questions at all. Hopefully that was discussed a little bit smoother now than it was this morning. This morning definitely had questions. Really? Nobody? No one will step up? Okay. Yeah, go ahead.
So when we do like the 10 to the negative 6, that goes in the gram area, like, I don't even know how to, so 1 microgram, like wherever the grams is where this goes? It doesn't.
When we go smaller, yes.
Okay, when we go small. When we go bigger, it's
Actually, no. When we go bigger, it's still with the grams. That's
It's
a
with
good
the
way to
grams.
remember.
Okay,
Yeah,
so that's
it'll always go with the grams.
Okay.
Okay. If you're following the notations, the powers of 10 directly off of that chart. Okay, and a few people will shift off of that, and we'll discuss that in a second here again. Okay. So if you want to stick with the chart and have those memorized, you can always put your conversion in front of the grams and you'll be set. Okay, you don't have to worry about anything else weird going on with it. Other things to address. A couple people said, why don't you just multiply by 1,000? What did they do? What those people did is they took the relationship between micrograms and milligrams back with relationship with grams, did all of the conversions in their head, and realized you just have to multiply by 10 to the third. Okay? Perfectly valid, but what you did was a lot of those calculations in your head. If you mess up those calculations, your answer is wrong, regardless of how well you understand the material. Okay? So please be aware of that. Writing it out will help you get that organized so that you don't make those really simple mistakes, because those simple ones are unfortunate and there's really nothing we're going to do to get you points back. Okay? Next thing, if this was a multiple choice exam, what are the answers shown? Could we come up with different ways to represent this same number? Yeah, we can come up with a variety of ways. 325,000 micrograms. Why would we typically not use this number?
There's a lot of zeros.
So we see a lot of zeros, okay, which makes it tedious to draw. But then another thing, what's interesting about those zeros?
Placeholders.
They're placeholders. They're not significant digits. Okay? So if we looked at that number, we might very well think that they were significant. Without that decimal point, we have no implication of whether they're significant or not. So what we might also see as an answer would be it converted into scientific notation. 3.25 times 10 to the 5th micrograms. That's a micro symbol. You just have to take my word for it. Okay? Why do we get to keep those 3 sig figs? Where are sig figs? So that for sure tells us that our answer has 3 sig figs, but the sig figs in our answer are dependent on the sig figs from what we used as our calculation. Okay, so we'd have to go back to each of those individual operations and evaluate the numbers of sig figs in each one of them. So what do I mean? In that very first calculation that we did 325 here. How many sig figs are in 325? We got 3 sig figs. How many sig figs are in 10 to the negative 3? Or for that matter, in 1, right underneath it. That one's a bit puzzling. What are those numbers representing? There are exactly 1, or 10 to the negative 3 grams is exactly 1 milligram. What does that mean about the significant digits in that number? If it is exact, infinite number of sig figs. It has no impact on our overall answer. What about the next one? It's again an exact conversion, which means again infinite sig figs. So the one with the least amount of sig figs is our 3 at the very beginning. That's what translates to our answer. What about the 1 that we added in there? I only see 1 sig fig right now.
325 over 1 is 325.
Okay. What we put in was exactly 1. So that 1 still has infinite sig figs. Because it's not 325 divided by 1.00001. It's exactly 1. Infinite sig figs again. Okay. So those sig fig rules will come back and keep pushing into you. You'll notice with the metric conversions, they aren't too bad. A lot of you, again, from previous classes, already have that King Henry thing that people have talked about and are able to do these 10 to the power manipulations fairly readily. Okay? If you're not one of those people, I'd say you're in a better boat because you'll at least write it out. Okay? Everybody else might skip it and they get the answer wrong for just, unfortunately, a mindless mistake. Okay? So if you write it out, you increase the odds of you getting the answer right. Are there other versions of scientific notation that we could use here? Or other ways to represent this? What we talked about in the morning. How about 32.5 times 10 to the 4th micrograms? Is that still the same number? Yep. Why don't we just write it 325 times 10 to the 3rd micrograms? Okay, this one gets a bit trickier to try and interpret on deciding what our answer should actually be. So for starters, the question would ask, put your answer into scientific notation. If it states that, which answer is right away wrong? The very first one. Because that's not in scientific notation. It may still accurately represent the same size, the same volume, the same amount, but it's not in scientific notation. Between the next three, we still have a number times the power of 10. Aren't those all scientific notation? Okay, I think I heard someone say no. Why? How did we define our scientific notation?
You can only have one significant digit before the decimal.
One digit before the decimal. Which means this answer is the only one that is fully scientific notation. The other two have the false appearance of it. Why would we use one or the other in different situations? It just comes down to what we're trying to manipulate. If you are asked for pure scientific notation, you should shift it to that format, only one digit beforehand. Okay? I know it's a bit tedious to do that, which would bring up the next point. I probably would never ask unless I was specifically asking for scientific notation. Does that make sense? Questions about our metric conversions? Because now what we're going to do is make it more difficult. Yep. Is everything metric? So the thing with metric that was nice is all we're doing is shifting placeholders. Okay? It makes things simple. We can tend to be able to deal with multiples of 10 relatively quickly and easily. What happens, though, if we happen to be in America and want to use metric units? Well, now almost all of our tools are set up in English measurements, American units versus metric units. Now we're all sorts of confused. We have to make sure that our conversions or our distances match. So when we compare across different continents or countries, we've got similar results. So to go through and do that, we have to have new conversion factors. So for instance, I don't know if you already knew this, an inch happens to be 2.54 centimeters. Okay. Interesting thing, is that a multiple of 10? No. Is it even like a simple, easy number, like just it's 4? No. Okay. Well, maybe the other ones are better. 1 pound is 454 grams. Well, that doesn't very helpful. How about 1 quart? 946 milliliters. Okay. We don't get these nice, easy conversions across. So what we want to do, or what we need to be aware of, is now how to set up our mathematics problems to account for these unit conversions without doing it in our head, because we can't do this math in our head. Okay, well, just a test, anybody. 1 over 2.54 equals? Nobody? Okay, good. There we go. We can't do these calculations in our head. We'll need to use the calculator, which means we have to make sure that we tell the calculator to do the calculation right. That's why we have to rely very heavily on dimensional analysis to make sure that we can organize our thoughts and our calculations to match. Make sense? Okay, next big fun thing, because of course there's always more. If we take a look at the footnote, what's the footnote say? When applying these equivalents, assume 3 significant digits. So before, when we were converting metric units, how many sig figs did we have in each of our conversion factors? Infinite, which was nice. We didn't have to worry about the conversion factor affecting our result. What's the problem with our English metric conversions? They're rounded, okay? We have to account for that sig fig rounding when we go through to do our conversions or our calculations. Okay? To make things a little bit easier to work with, when we go through and do these conversions, more than likely the amount of sig figs that you will translate through any calculation will be at most 3 sig figs. Why would we do that? I'm a really nice person and the numbers we're given are 3 sig figs. Make sense? So that would be the most we would expect, unless of course I gave you some new crazy conversion factor that incorporated more than 3 sig figs. One exception to that, the very first one, 1 inch has now been defined as exactly 2.54 centimeters. So that one is an infinite amount of sig figs. Okay? So when you're doing your conversions, at minimum, it probably makes sense, if they're your standard conversions that you're looking up, to always assume 3 sig figs or more than 3 sig figs. So that way you're kind of covered across those bases. Okay? Questions about that? So, next fun one. Let's see how you guys can do with this one on your own. The length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? I have provided some conversion factors for your viewing pleasure. Feel free to take advantage of any or all that you want. Sorry, I should resume recording. We start at the very beginning with 120 yards, and we're trying to get to centimeters. Okay, so if you happen to look up while I was drawing this, the very first thing I did was do my first conversion and say yard to centimeters. And then pull through all the lists. Do we have a direct conversion between yards and centimeters? No. So that doesn't work. So at this point, we either stall and sit there and just think of all the different ways that we can relate these two, okay, or we come up with something that we can convert it to quickly. Okay, so there's both options work. Is there a common factor between yards and centimeters? Anybody come up with one other than? Okay. We can convert centimeters into inches, but that's not yards.
We need to convert yards to feet, then do feet to inches.
So we can get yards to feet, feet to inches, inches to centimeters. So what we are doing is pulling of all the common factors that we could possibly slide in here to try and get our conversion to come across. So in this case, we actually thought about it before we put it down. So our first step was going to convert yards into feet. So we look at our conversion. 3 feet is 1 yard. So we've got that one there. So now we've got a problem. We've fixed the yard issue, but we've got a new issue. We have feet. I want centimeters. Okay, well, there's no direct relationship between feet and centimeters. Can I convert feet to something that I do have a conversion to centimeters with? Jump to inches. I know there's 12 inches in 1 foot. And I want to align those units such that they cancel as we go through. So each time I set up that new equation, I'm making sure that the unit I don't want, I see you, has to show up in the denominator. Yeah?
Do you have to memorize the conversion rates?
I'm still working on that, but I'm pretty sure no,
Okay.
because I can't have them memorized or don't have them memorized. What I'm going to guess is going to happen on the exam right now is I will give you a list, a big list of a whole bunch of different ones. And then you guys get to decide what conversion factors you want to use. Okay? I won't give you the conversion factor for that problem because that kind of defeats the point. You kind of can solve it right away. So you then
So, because we have 1 yard equals 0.914 meters.
about to get to that.
Okay.
I'll come back to that in a second. Yeah.
So like, will this test be like all multiple choice or is it going to be like, you know, all short?
I would like some short answer where I can see units, some unit calculations. We'll see what happens with that. It's going to come down to how much time I've got to put it together and how much time I feel like I can spend grading it will be the next issue. All right. So at this point, we're in units of inches. We'll use our last conversion to get inches over into centimeters, and we now have our final answer. The main reason I picked this problem is that there were a plethora of conversion factors. Is there another relationship between yards and centimeters that we could take advantage of? Instead of doing our yards into, what was it, feet? We could go through and convert yards into meters, because that conversion factor is also here. So what happens? 1 yard is 0.914 meters. Can I convert meters into centimeters? What's that relationship? 10 to the negative second meters in 1 centimeter. Which method would you prefer to do? Probably the shorter one, okay? Is either one necessarily different? Crunch the numbers. You find out that you do get a slightly different number at the end. Not a lot, but it is slightly different. Okay? The next issue that I kind of want to address on this, did somebody actually solve it this way?
Yeah.
Can you give me the number?
10,968.
968 centimeters. Calculator spits it out. Guaranteed this answer shows up as a multiple choice answer, and you would be wrong. Why? Sig figs. Okay, we didn't even talk about scientific notation in this. Your sig figs are wrong. How many sig figs are listed in your answer right now? 5. How many sig figs did you have to start with?
3.
Try again.
Oh, 4.
It's just 2. 1 and 2. The 0 doesn't count, no decimal point. So we only have 2 sig figs to start with. So the calculator answer spits out 5 sig figs. We have to convert that down appropriately. Before we officially decide 2, we have to go through and look at the other conversions. Yes?
Okay, so significant figures applies to each and every single
Every
problem.
single calculation you do in this class is sig fig dominated.
This is a
Yep.
significant figure.
Yep. Yep. Sorry. It's the way it works. Can't really do more than that. So, how many sig figs are in the next conversion? 3. How do you know they're 3? 0.914 for sure is 3, but what about that 1? Not technically infinite, actually. It's only infinite if it's an exact measurement. 0.914 is definitely not an exact measurement. How do we know it's 3 in both? Footnote. Okay, you'll remember it now. Okay, we've got assume 3 significant digits. Next calculation had how many? Why is it infinite in that last one? It's an exact measurement. Okay? There are exactly 1 centimeter in 10 to the negative 2 meters. We're looking at that unit prefix. Okay? In a nice way, all of the answers you spat out, okay, all still would have led you to the correct answer. We got 3s and 2s. Okay, so that's good. And it just technically you're wrong. It's infinite. Okay? So what does that mean our answer should be? 11? 10,968 centimeters becomes 11 centimeters? Still 11,000. Okay, we still go to 2 sig figs. Our insignificant our insignificant digit is greater than, I'm about to cover that, is greater than 5. So that means we add 1 to the prior, so we get our 11. It's 11,000 centimeters. Those zeros can be a bit ambiguous. We don't like that. So one of the things we could do is convert it into scientific notation. And if we converted it into scientific notation, we would get 1.1 times 10 to the 1, 2, 3, 4.
So is that why the two ways to get different answers, it's okay? It's okay.
Yep. Hi. Oh my God, ridiculous, right?
You get the same answer, because you can only get two things either way.
And you end up with the same answer,
Yeah,
both cases.
it's like 10,970 or something, so it's the same thing.
So I know we're really close and you're all really tired, but I want to get one last piece in here. We're done in officially 2 minutes, so we got enough time to kind of burn through this. Compound units. Okay? Compound units in and of themselves are a unit factor. And what do I mean by that? Our unit factors, we're relating two different units. So if we wanted to relate centimeters into meters, we know it's 10 to the negative 2 meters and 1 centimeter. There's our unit factor. It relates those two units. What happens with other compound units? Say like the speed. How fast did you get here in the morning? We could look at miles per hour. Give me your speed this morning, average speed.
75.
I guarantee it was not an average speed of 75 miles an hour, but we'll work with it. You got 75 miles an hour. Okay, so that's typically how it gets written out, right? Okay, that format is definitely a confusing format. Okay, another way we could write that, which I would say is much more clear, is that you go 75 miles in 1 hour. Very subtle difference in how we set up or evaluate our number and our unit, but it allows us to see the conversion factor. We can now see the relationship between miles and hours. What makes that helpful? Let's say you got here in 2 hours. How far away did you live?
150 miles.
You set up your conversion or your unit factor, multiply by 2, and you got it. One last one, I promise. Let's say instead you live 5 miles away. How long did it take you to get here? That one's a little bit different. We want the relationship between miles and hours. Do we know that relationship? For every 1 hour, how far did you travel? 75 miles. 5 divided by 75, we now have the time it took in hours to get here. Okay? So you can switch that, flip that unit depending on what you're trying to convert, just like we did with centimeters and meters. Okay? We can go back and forth on that. We will pick up there next week. Thank you for your patience for that last 2 minutes.